the mass and the weight of a body with a resultant force of 60 newtons will give an acceleration of 5 meters per second. First, we need to find mass. For that, we pass acceleration to the other side to divide. This is the formula for weight. We find mass in the formula before, and then we find weight. Now we only substitute. This is the formula for weight. Now we substitute.
Find the mass and the weight of a body if the resultant force of 200 pounds causes its speed to increase from 20 feet per second to 60 feet per second in a time of 5 seconds near the surface of Earth. With the givens. And the velocity 2 and velocity 1 we subtract, and it gives 40. And 40 divided by 5 is 8. And it gives feet per second squared because we have feet 1 and 2s, so it becomes squared. Okay, here we're going to find mass. And we replace it by the givens that we have. Force that gives us the problem, that is 200 pounds. And acceleration that we found in the last problem. And we replace it, and this we divide it, and it gives us 25 slugs. It gives us slugs because force is in pounds and the acceleration is in feet per second squared. And now we're going to find weight. We found mass in the past problem and gravity that is a given already, that is 32.1 feet per second square. It's feet per second square because we have slugs. And then we substitute and we multiply, and it gives us 802.5 pounds.
Assume a zero friction in figure 712. What is the acceleration of the system, and what is the tension T in the kinetic cord? This is the free body diagram. We need to separate them, so we have the first and the second figure. The acceleration comes from here, this part. So we have all the systems in X, or all the system, and the two mass and acceleration. That is the same to have force equal mass and acceleration. So these are all the forces in X, but we cancel friction because it's zero. We cancel the two tensions because positive and negative, zero. Here we have the force and, well, here. Then we substitute and answer here, blah, 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 and then pass to the other side, and we have acceleration. Okay, to find tension, we use the second free body diagram, and we use all the forces in X. So we have minus tension and plus 4 equals 0. So we pass to the other side and we see that force is the same as tension. We can also see here down that we use tension equal mass times acceleration. Mass 1, mass 2, substitute, and we can see that is the same answer as force in the other time.
Assume that the masses M1 2 kilograms, M2 8 kilograms are connected by a cord that passes over a light frictionless pulley as in figure 7.15. What is the acceleration of the system and the tension in the cord? No, no pudo. Okay, now we're going to find the forces of the system. We write weight 2 minus T minus weight 1 plus tension equals mass 1 plus mass 2 times acceleration. To find weight 2, we write mass 2 times gravity, and to find weight 1, the same was mass 1. And we cancel the tension because one is negative and one is positive. Then we write the mass 2 and the gravity, and then the mass 1 and the gravity. In this case, this is negative. And we replace it mass 1 equals 2, mass 2. Then have the answer and we subtract. And here we add and we have 10. Then we have 58.86 equals 10 plus acceleration. This 10 is multiplied here, so we pass to the other side to divide. And 58.86 divided in 10 is 5.886 meters per second squared, and this is our acceleration. Now we're going to find tension, and we can choose one of these two. It can be weight 1 or weight 2. And I choose weight 2, and I replace, it will be the same answer if we write the weight 1 or weight 2. So I replace it in here, and in weight 2 I replace it in here with mass 2 and gravity. And we multiply this, and this is the answer, plus the answer of this, and we add, and it gives us 125.568. And this is our tension.
Ya no sé la 39. Find the mass and the... ¿Cómo hablo, Emily? Sí, porque sigue viendo su perito. Sí, se me